everyone, welcome back to the channel of Ecoholics. This is another solution for IIT JAM 2023 paper for economics. We have started a series where we are solving solutions for the question of IIT JAM 2023 paper. So in today's video, you will be getting the solution for question number 16. Now, question number 16 is a pure mathematical question of the topic differential equation. Now, differential equation is a topic which you will find rarely, but whenever the question comes from that topic, it traps you in the calculation. So, differential equation is not difficult. First thing, it requires you to know the integration. Second thing, you need to be very patient while solving it because small things can help you reach to either your solution or to the next question in the exam, right? So this is a little bigger question, little bigger in the sense it will give us a lot of information and it will require something then. It is not only asking us to solve, but to get to an answer. So this is the differential equation given here. And these are some of the initial conditions given. So what are initial conditions? Initial conditions basically help us to find the value of constant of integration. Constant of integration find karne mein, these initial values help us a lot. Alright, so then after doing all of this, we have to find the value of dy by dx, where the x ki value is 2 and y ki value is alpha. So let's get into the video and let's be patient to learn the solution. I would recommend you to not skip the video in between because every single small step has its own value. Alright, so let me write the same equation on this page here. It is dy by dx. So I'm writing the same equation on the next page. X into dy by dx is equivalent to y into log y by x, where y and x both are strictly positive. Y at 1 is equivalent to e square, and the another initial condition is when x is 2, y is equal to alpha. These are the two initial conditions, and we have to find the value of dy by dx at 2 and alpha. 2 and alpha are the respective values of x and y. So it's going to be very easy. Let's have a look here. The first thing I would do is I would take this x to the other side so that I can get a homogeneous kind of equation. So this is a homogeneous equation as you cannot separate the variables. So it's not a separable equation. So in homogeneous equation, we always let y by x as v. And we always convert the equation into y by x form. So here, I will let y by x equals to v. So the equation would become dy by dx is equivalent to v into log v. This is what it would become. Now from this equation, y by x is v. So I would get y is equal to vx. So if I differentiate this, I will be getting dy by dx is equal to v into 1. So v into 1 because I will be using product rule as v is also a function of x. Then x into dv by dx. So I have used the product rule now. So from equation 1 and equation 2, both of them are giving me the value of dy by dx. So if I just equate these values, I would be getting v log v is equal to v upon v plus x into dv by dx. Now what I can just do is I can take this v to the other side. So I would get x into dv by dx is equal to v common. So I would get log v minus 1. This is what I will get. Now I will take this to the next page. So I have got x into dv by dx is equal to v into log v minus 1. Now I can separate the two variables. How? So the v variables I will try and keep on one side of equality and the x variables on other side. So I would be getting 1 upon v into log v minus 1 into dv is equal to 1 upon x into dx. Now, integrating this is little tricky here. It is little tricky here because how do we solve differential equations? By integrating. So what I would do is, I would let log v minus 1 as z. So let log v minus 1 as z, because doing this would give me, so if I differentiate this equation, I would get 1 upon v minus 0 is equal to dz. So now I can make the required substitution. So 1 upon v is equivalent to dz. This is z. And the one thing I missed in here was that dv will also come. Because v is further a variable of z, as we are letting log v minus 1 is equal to z. So I would get 1 upon v into dv is equal to dz. So I will just substitute the thing. The log v minus 1 ko I will be writing 1 upon z, whereas 1 upon v into dv can be written as dz. So I can integrate these two things together. Become easy. Just by 1 is outside, it became very easy. So 1 upon z integration with respect to z will be log z, and here it would be log x plus log c. C is the constant of integration, which we will find using the constant of integration. Okay? Now, what is log z? So, of course, both sides there are log. So, log will go away. So, I do not need to write log. I can directly write z is equal to. But this is log x plus log c. I know when it comes to log a plus log b is coming from log a into b. Because whenever we have log a into b, whenever we are taking log in front of a product, it can be written as log a plus log b. So, doing the same, I can write log. I do not need to write log. So, I will write one extra step here so that you do not get confused. So, it will be written as log z is equal to log xc. Now, log and log will basically cancel out each other by taking anti-log. What is the value of z? Z value is log v minus 1 is equivalent to xc. Now, I need to find the value of c. How can I find the value of c? It can be found using initial conditions. So, initial conditions are what? Initial conditions were when we read this initial condition, it means the value of y when x is equal to 1 is equal to e square. So, it means x is 1, y is equal to e square. So, when x is 1, v ko also you can substitute. This is log y by x. V ko we have assumed as y by x ko we have assumed by v in the beginning. So, I am just substituting that back. So, this means log e square by 1 minus 1 is equal to 1 into c. This is what you will be getting, right? Now, 1, what are you going to get next? Can you think how we are going to solve this? So, this will be log e square minus 1 is equal to c. Right? Getting my point? Now, coming to the next question, how we will find log e square? How can I find that? So, you know, natural log and exponential are just the inverse of each other. They are the inverse function. So, the 2 will come in front, log e. So, what happens is, if you write log e raised to power function of x, the function of x comes in front and log e is nothing. It is equivalent to 1. So, I just get my power. So, following the same pattern, I would get 2 minus 1 is equal to c, and hence c is equal to 1 is the answer here. So, I've got my constant of integration equivalent to 1. Now, the differential equation solution will become, this will become log y by x minus 1 is equal to x. Now, this is the solution of the differential equation. This is the solution of your differential equation. But I do not need to find the solution. I need to find the other value. What are the other values? I want to find dy by dx. But we haven't used this. So let's just try and use this also, because we will be getting what is that? Which says when x is equal to 2, y is equal to alpha. So the equation we have got is log y by x minus 1 is equal to x. This is the differential equation I'm taking. I will see, okay, if this differential equation satisfies this, putting the value gives me alpha, because y is equal to alpha, x is equal to 2. So basically these values given here are for x and y. But you put them if only when you get your solution for differential equations. So initial conditions are put to get the constant of integration. We haven't used this initial condition to find constant of integration, because this will not get us to the answer as it contains alpha. So I use the another one. Okay, I'm using this to get some values which might be useful later on. I do not know right now, but I will get to know later on. Minus 1 is equal to x, the value is 2. So log alpha by 2 has come out to be equal to 3. This is the value. I will keep it with me maybe for future use. Now I want to find dy by dx 2 and alpha. Dy by dx, so already it was given in the beginning of the differential equation. Because what is a differential equation? It gives you the value of derivative and you have to find back the value of y. So dy by dx is already given and we have found it here. But I wanted to find the value of dy by dx when x is 2 and y is alpha. So y is alpha here when x is 2. Which means this initial condition is going to get me to this particular point. So this is dy by dx. I just need to put the value of y and x, which are given as alpha and 2 respectively. Okay, so writing this ahead will give me dy by dx. I'm just writing the same equation. Y by x log y by x. So the only thing which you have to keep in mind is that this initial condition will help us to find the constant of integration, whereas this initial condition will give us some value for finding this value. Okay? But any which way, we have to come to this point. If we have to calculate the value of y and x dy by dx, I need to solve my differential equation. You cannot solve it directly. You will say, ki y and x ki value to given hai. So why do not we put it here directly? You can't put it because you do not know the value of y. Y ki value is attained when you solve a differential equation. Because y is the solution of differential equation. So y by x will be, I have to find dy by dx as 2 alpha. So y is alpha, x is 2. Log y by x will be alpha by 2. Now can you see log alpha by 2 we have already calculated, which is equal to 3 here. So 3 alpha by 2 is the answer. This is the answer here. So you will choose the option which will give you the answer as 3 alpha by 2. Alright, here it is. The option D is the correct option. I hope you will find this video to be useful and you will learn a lot of things from this video. If you like this video, please subscribe to our channel of Ecoholics at YouTube, because you will find more solutions to IIT JAM paper and there are a lot of videos which help you in solving questions. Share it among your friends so that they can also take benefit of the solution. Thank you for watching this video.